Differentiation, correct. The first one that we, so to speak, finished is graphing. Done. The second application that we are going to look at is called absolute max-min. Absolute max-min. Okay, we don't need to graph. Sometimes we will be graphing, we will graph these functions, but the absolute max-min. So let's take a look. What does it mean? So let's suppose we have this graph. I emphasize that it starts here and it ends here. And we already know by looking at this graph that the graph has right here a relative max, or local if you want to, if you prefer local, doesn't matter, relative or local. And we already know that this is a relative or local minimum. Now, when we talk about absolute, we talk about a function like this that starts somewhere and ends somewhere. And in this particular, for this particular graph, the relative maximum is also the absolute, also called global, use the one you like, absolute or global maximum. What does it mean? The function starts here, ends here. There is no other maximum anywhere. This is the absolute. It's the relative because the function exists on both sides. But it's also absolute because it doesn't have any other maximum. This is it. Now, if I have this situation, this will be a relative maximum, but this will be the absolute maximum because it's a higher value than this. So in this particular case, it's the same point, relative and absolute. Same thing here, relative minimum and also absolute minimum or global minimum. Here, this is a relative, but this is an absolute. This is a relative minimum, but this is an absolute minimum. Okay, here's another scenario. So here's another graph. We're going to look at examples in the book in a minute. But here's another graph. Here, this is indeed the absolute minimum and also the relative minimum because I can show the function exists on both sides. This point is nothing, like this point here is nothing, and this point here is nothing. It's not a max nor a min. Why? You can say, but it's a minimum. No, it's not a relative minimum. No, because I cannot show the function. The function does not exist on both sides. It's not an absolute because this number is, I don't know, 10, but there is one that is lower than it. So it cannot be absolute and it cannot be relative because it's at the end point of the interval. At the end point of the interval, we can only have absolute, but there is no absolute here because there is a lower minimum than this number. In this example, this is the absolute maximum, not relative. It's not relative because it's at the end point of the interval, and the function does not exist on this side. Relative requires that the function exists on both sides. This is an absolute minimum because there is no other value smaller than it for the y value, of course. And it's a relative minimum because the function exists on both sides. This is only absolute. It cannot be relative max because the function does not exist on this side. Okay, I'm going to share my screen right now and just look at a couple of examples. And I think I have it already here. Here it is. So before we look at examples that we will have to work on from scratch, notice find the absolute max and minimum values of each function over the indicated interval. So we don't have to do anything, basically. We are reading from the graph. But yes, we're going to do or perform our calculations in a minute, and I'll explain how. So let's choose one of these. And let's discuss the graph, and then we'll support our findings with our algebra or calculus. Okay, is anyone with me? I hope I didn't lose everybody. Okay, so let's look at 5. Can anyone tell us whether this function has an absolute minimum?
Would the absolute minimum be at 1, 4? No, that's no, 0.54.
So the absolute minimum, you are correct.
-2, 3.
-2, 3 is the absolute minimum. However, I completely agree with point something, 0.7, comma 4 point something. I agree as with that answer as a relative minimum. Fully agree. So this is a relative minimum, and it's somewhere here, maybe 0.7, comma 4.1. I completely agree. But the absolute minimum is correct. Awesome. Thank you so much. -2, comma 3. Do you all see this?
Yes.
Awesome. Does this function have a relative maximum?
1, 4.5.
Relative maximum. So endpoints,
Okay.
endpoints can never be relative. Yes, good.
Gotcha. Those are the absolutes. Okay.
If they are, yes, -1, comma whatever, 6.4, I completely agree. This is the relative maximum. Is it also an absolute maximum?
Yes.
Yes. So this point, the -1, comma, hard to read. Okay, 6.2, 6.3 is an absolute max and also a relative max.
Okay.
This point, 1, comma, blah, 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 is absolutely nothing.
Nothing.
0.7, comma 4.1 is a relative minimum, but not absolute minimum. And the only absolute minimum is here, -2, comma 3. And can this be relative? Is this a relative minimum?
No.
No, because the function does not exist to the left of -2.
Okay.
Awesome. And now let's support our findings from the graph with our calculus experience. So I am going to just copy the function. Let me just move one page away. So this is our page 2. And what am I doing? I'm copying 5. And 5 is on page 314. And this is f of x equals x to the third plus 1/2 x squared minus 2x and plus 5. And the closed interval is given to us -2, -2, 1. Okay, we know the answers. We don't care. We're going to do our work step by step. So we're asked to find absolute, relative, max, min. I also add the relative. The book does not ask you anything but absolute. But I also want to make a point in identifying if a max min that we find is a relative or not. Okay, that's my edit in. Good. So when I see the words max min and I'm given a function, what do I need to start with? when we are trying to find max min for a function, what do we need to find first? Exactly, of course. Here's your hint. Good. Can anyone dictate f prime for us? Good.
Square root of x to the second power.
So when I differentiate this, what do I write?
X, just
Thank-
X,
Good. And then here,
-2.
that's it. And 5 prime is 0. Awesome. Great job. Good. So we found the derivative. What is my next step towards finding max min? Nothing different from before. What is our next step? Okay, we're happy. Exactly. So thank you so much. F prime of x equals 0, or f prime of x equals undefined. It's a polynomial function. This will be a waste of time. So 3x squared plus x minus 2 equals 0. You don't have to do this, but I would like you to. You can choose any method you like. You can use a quadratic formula. But since we have this, and this is very important, now you know how to find the solutions. I know not all calculators have this feature. So the coefficients are 3, 1, and -2. 3, 1, no, yes, 1. And -2. Easy to factor or not, okay? So one solution is 0.6667. And the other one, x equals -1. Good? So now I have to put these in the table. Does -1 fit here? Yes. Does 0.667 fit here? Yes. Under these numbers, I know what I have to write for the derivative. That's how I found the numbers, by setting the derivative equal to 0. Now I have to study the sign of the derivative. So please plug in -2 here and tell me the sign. Plug in 0, that's the easiest. Plug in 0 and tell me the sign. Can anyone plug in 0 and give us the sign?
Negative.
Excellent. And when you plug in 1, 3 plus 1 minus 2 will be positive. And when you plug in -2, this will be 12 minus 2 minus 2, so this is also positive. Nothing new so far. We've done this before several times. Now, what is new? I have to plug in this number in the function. This is not new. I have to plug -1 in the function. I have to plug this number in the function. I have to plug this number in the function. So I'll share my screen. I'll go to the calculator. I go to y equals. I clear whatever I have. And I put in our function, x cubed. And then plus 0.5 x squared. And then minus 2x. And then plus 5. And now I plug in those numbers. Which numbers? -2, -1, 0.666667, and 1. And now I copy 3. I copy 6.5. I copy 4.2. And finally, I copy 4.5. I put them in my table. And now the moment of truth. Remember, this is when I know whether I made an error or not. If this row does not work well with this, then I know something is terribly wrong. So now let's try. From 3 to 6.5, yep, that's okay. It's increasing, that's true. From 6.5 to 4.2, yes, that's true. And from 4.2, yes, that's true. So now we have to identify what these points represent. And this is the most important part here, right now. Okay. So I'm not graphing the function. I'm just positioning these points. What do I mean by positioning? Okay, so this is 3. It goes up to 6.5. It comes down to 4.2. And then it goes up to 4.5. So this is the height of 6.5. This is the height of 4.5. This is the height of 4.2. And this is the height of 3. So first of all, what does -2, the point -2, 3 represent? And I'm going to write it right here. -2, 3. What does it represent?
Absolute min.
Yes, it's an absolute minimum. Is it a relative minimum?
Yes.
It's at the
No.
end point of the interval. So only absolute. Awesome. This point, -1, 6.5, right here, this point, what does it represent?
Absolute max.
Yes? Is it a relative max?
Yes.
Yes. Because it's not at the end of the interval. Awesome. Now we're talking about this point, 0.667, 4.2. What is this?
Absolute min.
Careful. It cannot be the absolute because we already found an absolute. It cannot have two absolutes unless they are the same value. If this comes down to 3, then we have two absolutes, but the same value. So it cannot be absolute.
Would it be relative min?
Yes. I know this relative min because this is the sequence of signs. Negative, negative, 0, positive. Awesome. Finally, 1, 4.5, this point. It cannot be relative. Can it be absolute max? No, I already have it. Can it be absolute min? No, I already have it. So then what is this point 1, 4.5?
Nothing.
Nothing. Nothing indeed. So it's a very good visual exercise to put these numbers in perspective, right? And also remember, increasing, so this is the absolute max because it's positive, negative for the derivative, and then a minimum because of the sequence of signs for the derivative. That's all you need to identify.